Good morning and welcome to PWN Physics 365. Physics every single day of the year. Physics past, present, and future. The podcast doors are closing.
Alright friends, hello and welcome back to PWN Physics 365, where we do physics every single day of the year. I'm your host, Eli Hibbett, and here we are on the 31st of January 2016. So if you've done every single episode so far this year, congratulations. We're 1 month down and not stopping anytime soon. So let's take a look on this day in physics, the 31st of January in 1982. A white dwarf companion to the star Sirius was discovered. Well, it's actually not a star, it's a white dwarf. Is discovered by Alvan Graham Clark using an 18.5-inch telescope. Sirius is the brightest star in the night sky. It is now known as Sirius A because of this discovery, which saw that a second white dwarf star, Sirius B, exists and orbits Sirius A. They actually form a binary star sequence. So this dude with his relatively meager 18.5-inch telescope was able to identify that a second white dwarf was in the sky. So that leads us to our word of the day, white dwarf, which is a type of star leftover, which is considered to be the final stage of stars which are not massive enough to become neutron stars. These dwarfs were once small to medium mass stars. Then they entered their red giant phase, which have very large radiuses with relatively low temperatures, 5,000 Kelvin or less, which for stars is relatively cool. Red giants are essentially giant fusion reactors which fuse helium into carbon, releasing massive amounts of energy. When they run out of energy, what you're left with is a white dwarf. It's the core of the reactor which doesn't have enough energy to react anymore. Imagine the nuclear waste in a nuclear reactor once it's been used up. They are extremely dense. Imagine something the size of the sun compressed down to the size of the Earth. White dwarfs in this stage radiate out tons of energy in the form of white light, and as they have no source of energy, they simply lose this energy, dim, and fade away. The white will get slightly redder as it ages. They should reach a point of cooling where they will no longer radiate light and will become the theorized black dwarf. There are no known black dwarfs to exist. The amount of time that it takes a white dwarf to cool to the black dwarf stage is longer than the current age of the universe. We may see some in the future, but the coolest and oldest white dwarfs known to exist are still a few thousand kelvins. So, that's the deal, guys. That's what a white dwarf is. And I was thinking about keeping, the 3 segments together, but this killer resource is awesome. It's a YouTube video, and it's drums and cymbals in slow motion. World record-holding drummer and current Dream Theater drummer Mike Mangini was filmed with high-speed cameras to see how drums behave in slow motion. And when you see this dude hit drums with his drumsticks in slow motion, the drum heads and cymbals, and you think like a snare drum has a very tight surface, when he hits it and you see these waves radiate through, man, it is phenomenal looking. You never seen anything like this in your life. So head on over to the blog, pwnphysics.blogspot.com, and check out the 30th of January 2016 entry for that video and much, much more. Links to the other podcast, just read the regular PWN Physics podcast, and links, of course, to the App Store. I do have a wide variety of physics-related apps to help you on your physics journey. So do head over to the blog, again, pwnphysics.blogspot.com, and that's going to do it, I think. 1 month down, 11 to go. So I hope you're digging the podcast, and I hope I will see you again tomorrow. I see the music is on its way, so I will let you go on your way, guys. I'll see you tomorrow. Take care.
The pod bay doors are reopening. You may now resume normal life functions.